Okay, guys. Today, before we end the day for today, let's do this question paper, right? This question paper is for it's for this year. Uh, the last what you call last examination of this year's 15. No, so let's do question number one first. We're going to do question number one because now we already done question number one, question number two. We done question number three, up to number three. So that means we already done 60% of the question paper because it's 20 marks, and then another 20, right? So today let's check how far we can answer this question paper, right? So the first question on this question paper, they say define the terms according oh define the terms concerning fluids and write down there what you call the unit of measure for each of or for each one. So you have the specific weight, the relative density, and then the tension, the surface tension, right? So we spoke about this one. We say the surface tension, start with surface tension is measured in Newton per meter. I shouldn't be writing here. Let's write it here. So it's this one is measured in Newton per meter, and then the definition of a surface tension, we said this is the resultant of force acting towards the interior of a liquid. So we said the surface tension is actually the forces that holds maybe they say it's the droplets hanging on, maybe on, let's say maybe on a roof. So the forces, the interior forces that are acting here, if the interior forces are is bigger than the one on the outside, it's causing these droplets to stick on what on this roof now, and then you say that this one is that is a surface tension. It's because this one is said is due to the cohesion forces that are greater than the adhesion forces on the droplets. No, so the cohesion and the adhesion forces that are acting on this droplet, if it is greater than the other one, are causing what the resultant force. And then we have what your surface tension. Number two, have your relative density. Your relative density, this one we say is the ratio between what relative density. Remember, say relative density, we can calculate it with what, with this formula of what density of what of the substance over density of what of water, yeah, like this. So this one it's going to be what as the ratio between what the density of what of the substance and the density of water, or it can be the density, or it can be what the weight of the substance over the weight of what of of water, yeah, of water this side. And then we have the specific weight. The specific weight is the same, but then the specific weight it's always given by what, by the density and what, and gravity. So it's actually the product of what, of the density and the gravity of what, of the substance, which is what the specific no. Or else you can also calculate if you check here on your formula sheet, your specific weight, you have two types of, or it's the same. So your specific weight here is what, it's weight over volume. So Here I was proving that weight over volume is still what is still specific gravity, because weight is measured in what? Weight is measured in Newton, and then our volume is measured in what? In cubic meters. So they're giving us it as a unit of what? Of Newton per square cubic meters. And then when we check the other one that says what you call density multiplied by gravity. So our density is in kilogram per what? Per cubic meters, multiplied by our gravity is in what? In meters per square second. So this is the acceleration. And then we know that on Newton first second law of motion, force is equals to mass multiplied by acceleration, right? So that says kg multiplied by what you call it by acceleration, which is meters per square second. So now acceleration, which is meters per second multiplied by the mass here, is still giving us what? Our force, which is measured in Newton, this one. So force per cubic meter is still what? Is still our specific what? Specific weight, right? So then we can say that our specific weight is measured in Newton per square meters, or it can be measured in what? In kg per cubic meters. Yeah, then meters per square second, still the same thing, but then we can prefer this one because we're talking about specific weight. Okay. And then let's go to question number 1.2. They say here we're having a 300 liter drum. It's filled with oil with a relative density of what? Of 0. What you call 0.96. So in this case we are having what? Our drum is filled with what? With 300 liters, and then a specific gravity or relative density of what? Of 0.96. So here they said calculated the specific weight, the specific weight of what? Of this oil. So we say specific weight is what? Specific weight is equals to density multiplied by gravity, right? Or you can say the weight of the substance over the weight of water. But then we can use what? This one. So you're going to use what? The formula for this one as relative what? The relative density is equals to the density of the substance of water, and then we have the relative density, which is 0.96 multiplied by the one of water, which is going to give us one the relative density of the substance, which is the density of what? Of the oil, multiplied by 9.81, and then we get what? We get our specific weight, right? Simple as that. Specific weight. And then the other one, they say now calculate what? The weight of the oil. So the weight of the oil now that means we need to calculate what? Weight. And then weight, we can also calculate weight by saying weight is equals to mass times gravity, right? So we don't have mass, gravity we always do have. So we can use by use the formula of density is equals to volume sorry mass over volume, right? So this volume, it can be, this one is our volume, which is 300 liters. Remember we said a liter, 1 liter is equals to what? 1,000 is what is 1,000, right? 1,000 cubic meters. No, and then we can use one this formula to get on our weight. So that means our weight now, we can calculate the mass and put it here and get what our weight. So we can then say it our mass is equals to gravity, or sorry, density multiplied by volume. So our density is going to be 0.96 multiplied by 1,000 multiplied by our volume, right? Which volume now is going to be equals to 1. Yeah, it's going to be 1,000 liters. So it's going to be 3,000 multiplied by 1,000 and get the mass, and then we put it here to get what our weight. Simple like that. And then now let's do something like something that is serious here. So here we're having what you call 1.3. 1.3, we're having the say piston moves or slides, no? Inside what you call inside our cylinder at an average velocity of what of 3.26, and then the cylinder has an inside diameter of 310 millimeters, and the piston diameter is what it's 309.5 millimeters with the length of this one, and then the piston is lubricated with oil with the coefficient of this one. So we can put this one like this. We can say we have this this is our piston. Let's put our rod here. This is our piston like this. They say now you are having this piston here moves at what at this one. This is our speed now, which is 3.25 meters per second. And then they say that the cylinder has an inside diameter of what of 310. That means this is our cylinder. It has what an inside diameter of one. So the diameter of the cylinder is 310 millimeters. And then we have the diameter of the piston. Now this is the diameter of the piston here, which is there's a small letter d, which is equals to 310 9.5 millimeters. And then they said this piston, it has a length of what of 200. Let's say this one has the length of the piston, which is 200 millimeters. And then the piston is lubricated with oil with the coefficient of friction, the coefficient of viscosity. That means we are dealing with what you call with our viscosity. So the coefficient of viscosity, which is this one, which is equals to 0.196 Pascal second. Okay, so our first question now, they say we have to calculate the force to overcome what to overcome viscosity resistance inside the cylinder. So we said on our previous video said force to overcome friction, or force of friction, as always equals to what, the coefficient of friction multiplied by the area. But this is what you call the area of contact multiplied by the speed over the clearance. Now, so we can start with the clearance. The clearance, we say, is the difference of what of this diameters divided by 2, because the clearance is this space here. Let's say this space is what, this is our clearance, and then also on top this one is the radial clearance, which is going to be d minus d over 2. And then don't forget to put this one in meters. So it's going to be 0.31 minus 0.3095 over 2. And then you get what? We get our clearance. Let's just punch first. Uh, 0.3 minus 0.05 over 2. And then just put 2.5 times 10 to the power negative 4. So this is radian in meters. And then another thing that we need to calculate now is what is our area. No? The area of contact. So the area of contact M, which is this A, will be equals to remember, say the area of contact will be the what you call the circumference of what of this the circumference of the piston multiplied by the length of the piston, and then the circumference of the piston multiplied by, which is going to be 0.3095 multiplied by the length of the piston, which is going to be 0.2, and then you get the contact area. No? So 1 of 4 is going to be pi. So pi, what am I doing? Pi times 0.3095 times 0.2, and then we get 0.1944 meters. And then we can put it here, and then we say our coefficient of friction is 0.196 multiplied by our area of contact is equals to 0.1944 multiplied by 3.25, which is the speed over the clearance, which is 2.5 times 10 to the power negative 4. And then we can put it here and say this is 0.196 times 0.1944 times 3.25 over 2.5 exponent negative 4. So that means the force is equals to 495.33 Newton. Yes, so this is your force. So this is the force to overcome your friction, right? Is this question now. So the last one, they say can get the power due to viscosity. So always know that power is equals to force multiplied by velocity, or our velocity is what is this x. So it's going to be this 495.33 times our speed, which is what 3.25, and then we get our power. So I hope that all the formulas that we are using, they're here on our formula sheet. So see, on our formula sheet we have what formula for your density, specific gravity, which is your relative velocity, specific weight, formula for pressure, formula for the absolute pressure. Also, this is a pressure gauge. This is the formula for the surface tension. Also, this is together with the surface tension, which is the change of the internal pressure, or the change in pressure, which is equals to internal pressure. The outside pressure is equals to 2 times, this is the surface of the what you call this one is the surface tension or the radial. Yeah, this one is the surface tension, né? The coefficient of surface tension. This one is the radial of the droplet, or the radius of the droplet. And then this is the formula that we're using right now, the viscosity. But then they say they put a T here. It's not exactly the one that we're using, but then it's this one, and then it is a formula for. So everything it's here. This one is for the bulk modulus. The this is a strain, the volumetric strain, the bulk modulus, and then also this is a bulk modulus of the contract. So everything that we've been using up to this one is the one that we're discussing not so long on our previous video. So that means we have dealt with our formulas up to here for now, and then we'll see we're left with only this one. So stay tuned. We're going to do another video continuing on this formula, on this question paper. We're going to do question number 2. So somebody was complaining about question number 2, so we'll do question number 2 using this question paper. I'm not going to do the basic stuff, because this one we know the Pascal law, how to convert this thing. This is the simple hydraulic press that we have done on N3 and N4. So we'll do this one on the next video.